Okay, then after that, next one.
They don't intersect each other.
They don't intersect each other. Okay, if at all, if they intersect each other, what is the meaning of that? They don't intersect like this. Okay, if at all, if they intersect, what will happen? Means it is showing two different fields at the same point, which is impossible. It is showing two different fields, two different directions at the same point, which is impossible. Okay, that's the meaning of it. Okay, now, so now one more thing I would like to explain here. See here the magnet, how he is comparing. What is this? This is a bar magnet. And what is this? This is a solenoid. And what is this? This is the plates, positive plate and negative plate. So what he is doing is he is comparing a magnet, a bar magnet, with a solenoid and a plate, that is positive and negative plate, or plates of a capacitor, you can say. So all are showing the same. All are showing the same. See here, magnetic lines of forces start from north and the end at south. So solenoid is also acting the same way. Whereas this is what? So it is starting from positive, ending at negative. But only the thing is, it doesn't form a closed loop like this. These two form closed loop, but this doesn't form a closed loop. Only that is a difference between a electrostatic and a magnetostatic. Keep that in the mind. Now, next one. We'll go with the yesterday's derivation quickly. We'll just quickly do the derivation. Then we'll go with the two derivations. Just I will do a recap. Okay, clear? If you have done already, just you can go through. Otherwise, you can just copy it at 1 second. Now, bar magnet as an equivalence or not? So, bar magnet as an equivalent solenoid. So, what we say, suppose this is a solenoid, okay? This is a solenoid, and this one is what? This line is the, what is this line called?
Equatorial.
Equatorial or what? Axial line. Very good. That is an axial line. Okay. What about this line? What about this line? Equatorial line. Very good. This line is equatorial. Okay. Now, quickly tell me, what is the small element? How much is this? This is dx. This is dx. And what is this one? This one is what? X. X. Okay. From the center to the element. This is current element. If I am saying that the current is flowing through that, then I say it is a current element. Clear? Now, that is total distance is how much? Length of the bar magnet is how much? 2L. Is that clear?
Yes.
And this one is how much? L. Okay, this one is L. Now, from here to here, how much? From here to this point. The total length, let it be R. From here to here, let it be R. Okay, from the center. Then this will become how much? From R, you have to remove this X. How much it will be? See, this from center to this point P is what? R. Now, you are going to remove this X from R. How much it will be? From here to here, it is R. From here to here, how much it will be? See? Okay, let it be. I write it here. X. How much it will be? Like R minus X. Here, R minus X. Is that clear now? So this part, now what I am going to do is I want to find out the magnetic field at point P due to the small element dx. I want to find out magnetic field at point. This is little difficult, this derivation and the next one. Okay. So this at point P, I want to find out the magnetic field due to the small element. First, I want to find out that. So for that, I am using Biot-Savart law. There are two laws. So Biot-Savart law and Ampere circuit law. These are the two laws. What they will tell? How much is the magnetic field around a current carrying conductor? That can be found using the two laws. So I started with the first one. Biot-Savart law. What is the formula for Biot-Savart law? dB is equal to how much? dB is equal to mu 0 by 4 pi into how much? Into I into dl cross R by I into dl cross. See once again quickly. Suppose I is the current in the conductor This is a small element. DL is a small element. I into DL will become current element. I want to find out the magnetic field at point P, which is at a distance R from the current element. And the angle between both of them is theta. Is that clear? So I DL cross theta divided by R cube. This is the formula what we have discussed before in the 4th lesson. The same thing I am going to use it now also. So he says that, but here one more thing comes into picture. What is that? That number of terms. How many number of terms? So total number of terms are n. Here I'll write that also. Capital N is what? Total number of terms. Okay. Capital N is total number of terms. And what is small n? Small n is number of turns per unit length. Number of turns per unit length. That is product. That is small n. Now small n, and we have 2l. What is the 2l value? Total length. Total length of the bar magnet. Whenever we write the length of the bar magnet in the numericals, you have to write 2l. Never write l. You might ask me, sir, why do we write like that? Because the center from here and here is same. The magnetic field strength here and here is same. Only it is differentiated by plus QM and minus QM. Means this is north pole, we write plus QM. If it is south pole, we write minus QM. Even in the dipoles also we write 2A. We don't write A. Is that clear? In dipole also we write 2A. We don't write A. That is the difference. Okay, one should know about this. Now, so total length of the bar magnet is how much? Total length is this much. So now small n is equal to 1, small n is equal to capital N by 2L. So just cross multiply. N is equal to small n into 2L. Is that clear? So this is about the number of turns per unit length that we got it. Now we want to find out the magnetic field at point P due to this element. Then what I have to do? I have to make a complete a triangle. Okay, is it not? So I will draw a triangle now, a right angle triangle. Okay, so this is what? This value is A. This is the radius. Small a is what? Small a is radius. Just type. Now, so small a is radius. Okay, so therefore this is A. This is what? R minus A. So what will be this value? R minus X. So what will be this value? Very good, very good. And square root of R minus X whole square plus A square. Okay? Hypotenuse square is equal to opposite side square plus adjacent side square. Okay, we can calculate in that. Now we got the distance now. So we'll just substitute in the formula. What is the dB? dB is equal to, he writes here, dB is equal to mu 0 and I dx A square divided by 2 into R minus X whole square plus A square whole to the power of 3. Yeah, this is the value. One second. Now, what is n here? Small number of turns per unit length. How many number of, because I'm not sure how many turns are there in the dx. How many number of turns are there in dx? I don't have any idea about that. So for that reason, I'm writing small n. Second thing is, what is IDX? IDX is the current element. The same thing we wrote here, IDL. There it is IDX. Okay, then what is A square there? A square is the radius. Radius. Okay, square of the radius. The denominator is the same again. What is that? R cube, no? Here. Or if you remove this, R, the formula will become how? See, dB is equal to mu 0 by 4 pi into I into dl divided by R square. IDL sin theta. IDL sin theta divided by R square. Can I write like this now? Because this R and this R will go away. I'm left with IDL sin theta by R square. Because it is 90 degrees, we don't write that sin theta. Sin 90 value is 1. Because that is perpendicular. Magnetic field and the conductor both are perpendicular to each other. So therefore, we are not writing sin theta. Is that clear now? So he wrote this formula directly. How did this come? Because in this small element, how many terms are there? Maybe there are 1, 2 wires, 3 wires, 4 wires. I don't have any idea. For that reason, I am taking smaller. That is the only reason. Actually, this was deleted last year. Again, they added this year. Okay. If you go back to the C from last 3 years consecutively, if you see, there is so much changes. Sometimes they are adding, sometimes they are removing. So I was thinking that this is deleted this year also. But when I saw the syllabus, then I came to know that this is also there in the portion. Okay. But it is very easy. Don't need to worry about it. Now what we are going to do is I want to find the entire magnetic field, full magnetic field. So what is the B? B is for the entire magnetic field. Is that clear? If I want to find out the magnetic field, full magnetic field means due to the full coil, the full solenoid. So we write B. But keep that in the mind. Whenever we want to find out the magnetic field, full magnetic field, and we have a small value, either we use summation and we use integration. We use for the whole thing, we use summation. This is summation. Okay, this is summation. And what is this? This is integration. Okay, this is integration. What is the difference between summation and integration? Any idea?
The integration is to find the area under the curve.
Very good. Area under the master.
Yes.
Oh, you know very well. Area under the curve. Yeah.
Summation is to find the total value.
That is okay. What do you think, Aaron? Where do you use summation and where do you use integration? This I discussed many times in the class. Summation when we have discrete values. We have discrete values. Like we have 2 notebooks, 4 textbooks. We want to put it together. We say summation. Okay. Integration when you are speaking about the same water, the same liquid, same substance, means of the same quantity. Then we use integration. Because we are speaking about the magnetism, entire magnetism. So can we use integration? Yes, we can use integration. Is that clear? So integration makes you simpler rather than summation. Means summation, we can use summation of all the books, summation of all the pencils, summation of, then we can put it together. That is summation. But whenever we have discrete, keep that in the mind. Whenever we have discrete values, okay. Whenever we have discrete values, we use summation. And whenever we have continuous values, we use integration. So this fellow, what is his name? Ampere, he used integration for that reason. Anyways, I am going to find the full magnetic field only. Why will I waste my time in doing summation thing? I'll not use summation. He used integration for that reason. Got it? Okay. So now I'm using the entire magnetic field. So B is equal to how much now? B is equal to, I'll write mu 0. See, all are constants. N is constant. I is constant, A square is constant, divided by 2. 2 is also constant. Is it not? Divided by 2 is constant. From where to where? Dx divided by r minus x whole square plus A square whole to the power of 3 by. Okay. Whole to the power of 3 by. From where to where? Minus L to plus L. Is that clear?
Yes.
From where to where? From here to here. For the full solenoid. To the full solenoid. Now we also know that R is much greater than X and R is much greater than A. According to the definition of a solenoid, radius, the R value, this value is much greater than the X values. X is very, very small. And also R is much greater than A. Is that clear? So we are going to remove that all those things. So it will become what now? B is equal to how much? B is equal to mu 0 and I A square divided by 2 minus L to plus L dx divided by what? What else is left here? Only R square will be left. X is also very, very small. A is also very, very small. Only R square. It will be like this. R square whole to the power of 3 by 2. So 2 and 2 will go away. R cube will be remaining. But R is a constant with respect to dx. R is a constant with respect to dx. So I'm taking R square outside. R cube outside. Is that clear? So only dx is left inside. Is that clear now? Okay. Copy this. Then is it clear, all of you? Both of you clear? Okay. In India, no one wears mask. Nothing. And if we are wearing mask, they
Judge.
yeah. least in the airport, they are very particular. Airport, they said they have to wear. That was good at least.
Then you did nothing.
Nothing. It came from Mumbai. Mumbai was the first trip from.
So we went to Chandigarh from here first. So there was a lot of strictness.
Lot of
Strictness. We were checking bags also by the way.
Chandigarh is a good city. Next two topics are very small. Okay, electromagnetic. This is magnetism. Magnetic induction is a very small chapter as well as alternating currents is also a small chapter. You can finish in 2 sessions like that. Okay, very fast we can finish that. So once we are done with this, we'll start optics also. Okay, but you have to write the test. Okay, you submit it. Madam, you haven't submitted. You have to submit. Okay, and see, it's a practice. Okay, don't think that it's like something like I'm going to judge here. I'm not judging me. It's like a practice test. Clear? See and write. Not I don't have any issues with that. You have to. If you're able to write without seeing, it's okay. If you're not able to do it, see and write at least.
Magnetic induction.
We just started. Actually, I thought like few topics were deleted, right? When I saw it after that, then I came to know that. What is that? Okay. So we will solve this integration part. Okay. Now the last part is pending. So in integration part, see here, what is that? D is equal to what? D is equal to mu 0 and I a square divided by 2r cube. So what is that? Dx now. So dx will become, see, integration of dx, the value will become x. Okay. That value will become x. So from where to where now? Minus L to plus L. So what will happen now? B is equal to mu 0 and I a square divided by 2r cube. From where to where? L minus of minus L. Okay. L, that means upper limit minus lower limit. This is the upper limit and this is the lower limit. Upper limit minus lower limit. So B will be equal to what? B is equal to mu 0 and I a square divided by 2r cube into 2l. Clear? 2r cube into 2l. This is the value now. Now I am going to multiply 2 and divide by 2. Clear? I am going to multiply with 2 and divide by 2. So what will happen now? B is equal to what? Mu 0 and into 2l. I am putting it together, arranging that one. Okay. then after that then after that then 2 I'm multiplying here, and pi also, pi a square. Okay, so what I have to divide with? 2 pi also I have to divide. 2 into 2 will become 4, 4 pi r cube. Is that clear? Divided with divide, I write here, divide and multiply by 2 pi. Okay, why? Because see here, m is equal to what? Nia. What is n? Number of turns. I is the current, A is the area. Okay, so if you see carefully, m is equal to what? N is small n. See here, I wrote somewhere. What is, where is that? N is equal to number of turns per unit length. If you cross multiply that, n is equal to n into 2l. Okay, so I have that n into 2l here, and then I have pi a square. Is it all there? See here, n into 2l I pi a square. Do you have this one? So can I write here now? The next step. So I'm writing here b is equal to what? B is equal to mu 0 by 4 pi into 2m by r cube. Finish. This is for what? Axial or equatorial line? I'm finding on this line. Axial line. Very good. Got it now?
Yes.
It's very simple. Now the next one is what we have to find out for equatorial line. So what is that equatorial line? For equatorial line, what is the formula? Mu 0 by 4 pi into 2m by m by r cube. Is that clear? Now tell me. Okay. Now tell me, what is mu 0? What is mu 0? What happened, Aaron? You forgot everything. Forgot everything. What is mu 0? What is epsilon 0? Permittivity of free space. What is the meaning of permittivity? Allow. Permit. Means what? It's a property of the medium which allows the electric lines of forces to pass through it. That is permittivity of free space. Okay. Permeability of free space means there is electric lines, and this is magnetic lines. That's it. It's a property of the medium which allows magnetic lines of forces to pass through it. That is mu 0 and 4 pi. And m by m is a what is it? M, small m here. Magnetic
moment.
Very good. M is magnetic moment. Right? That okay. M is magnetic moment. Okay. The formula for magnetic moment is Nia. Okay. Is that clear? So that like electric dipole moment. We have electric dipole moment, right? You remember? 2qa into q. The same way. Here q is replaced with current. A is replaced with 2a. That's it. That's the only difference here. Got it? Okay. So can I go for the next one? The dipole in a uniform magnetic field now? Okay. Is it clear, this derivation? Thoroughly. Okay. So what you will do is, after going to home, just find out 10 minutes. My class won't take much time. When you go home, after like evening, whenever you feel, on the same day, whether it is 9 o'clock, 8 o'clock, 10 o'clock, close this book and write this derivation, see once, finish. And it will remain in your memory for a long time. That is the secret of success. What we do is, we just start working one day before the test. What is happening? The effort will be more. You do it once and see what will be the difference. Okay. Today, anytime before you sleep, write this derivation on a blank paper. We can do it more. We can do more, and it will be there in your memory for a long time. That is the secret of success. Any subject, not only physics, whether it is chemistry, whether it is bio or whatever, you do it on the same day. Find out at least half an hour for yourself and do it whatever you have done. Is that clear? Otherwise, no, it will pile up. The next day it will pile up and it will become very difficult to remember. Practice. Okay. Clear? So next one. Okay. So the next one, torque we will see now. So what time you will be going there to the institute? 12 o'clock. How will you go? That dropping. That's good. So you'll go back now to your place and get ready. Good, very good. Carry some food also with you, okay?
So we don't get anything.
No, you have to carry. That's what I'm saying. Huh? It's very hot also. Don't come down also. It's very hot. Yesterday also it was very hot, no?
I don't feel.
So the dipole in a uniform magnetic field. We'll do this. So this is the uniform magnetic field. The figure is not given in the book, but this is how it is. There, okay. So this is the magnetic field, and this is a dipole. Okay. Dipole means a north pole and a south pole. So instead of writing north and south, I'm writing plus QM and minus QM. Okay. And the distance between both of them is 2a. Is that clear? It's written in that way, just like a dipole. So what is the formula for tau? Tau is equal to m cross b. Okay. Like same way, no? In electrostatics, what do we write? P cross E. Do you remember this one in the first lesson? Tau is equal to P cross E. Here P is replaced with M, E is replaced with B. That's the only difference. Now the next one, what is that here? Tau is equal to, okay, we can also write tau is equal to what? Tau is equal to MD sin theta. Is that clear? Tau is equal to MD sin theta. Why? Because A cross B is equal to how much? AB sin theta. From there we wrote this one. Yeah, A cross B is AB sin theta. Done. So this is the first. Let this be the equation number 1. Okay. This is said to be applied torque and restoring torque. We have tau is the restoring torque and theta is the angle between M and B. So we have restoring torque. This is a restoring torque. Okay. Tau is the restoring torque. Now we also have tau is equal to I alpha. Tau is equal to I alpha. This came from where? This is, let it be equation number 2. This came from rotatory motion. When anything is rotating in a field, then there is a torque. Okay, tau is equal to I alpha. What is I here? I is moment of inertia. Okay, I'll write here. I is moment of inertia. Okay, I is moment of inertia. And what is alpha? Alpha is the angular. Is angular. Angular acceleration. Theta, I write it. See, theta is angular displacement. Keep that in the mind. Okay. Theta is angular displacement, and omega is angular velocity, and alpha is angular acceleration. See, there is a difference between circular motion and rotatory motion. You know the difference between that? Circular motion and rotatory motion. See here. Suppose this is the now here. This is the center O, and this is the body. Okay, this is the body. This is moving in about a fixed point. Then that is said to be a circular motion. Rotatory motion means what? Now suppose you draw an axis through a body and rotate that axis. When you rotate that axis, the body will rotate. Simple example for this is what? A top, Beyblade or top. Okay, you just put it. Then what happens? It rotates about its axis. That is a rotatory motion. Circular motion is what? About suppose this is you tie a thread, stone to a thread, and it starts moving around it. Most of the students they think that circular motion and rotatory motion is same. Got it? There is a lot of difference between a circular motion and rotatory motion. Motion of the earth around the sun. Circular or rotatory? Circular. Motion of moon around the earth. Circular. Motion of earth about itself. Very excellent. That's the thing. You got the difference now? Rotatory motion and circular motion are two different. This is taught in grade level. Okay. Anyways, this is a difference. Simple difference between. Anyways, okay. I don't want to criticize anyone, but here, these are small things. Okay. One should be very clear. See, when the topics are clear, when it is physics, chemistry, bio, whatever it is, you'll start loving it. You start moving more into the topic. That's the difference. Okay. Now you got the difference now? Rotating. So what we are speaking about now? Are we speaking about a circular motion or rotating motion here? Here.
It's circular.
Think. Okay, I'll just help you. This is the center of the dipole. Very good. It's rotatory. See, this is a dipole, man. Now dipole. See, the dipole. It is trying to align in the field. It is trying to opposite. So about what? See, about what? About a fixed point, right? It is happening about the axis. It is happening about the axis. Circular means it is moving like this. No, this is the fixed point. It is moving around that fixed point. This is not moving, no. Is it moving in circle?
Like O is a fixed point.
It is axis. This is the axis.
It can't.
No, man. I mean, this is the axis, man. O at point O, there is axis. Mean like this is the dipole, man. This is the axis. It's moving about this point. Got it now? That is a rotatory motion. Got it? Circular motion. Simple way to remember circular motion is motion of the earth and moon. About itself means rotation of about itself. And the top is the best example. Beyblade is an example. Best example to remember. If you want to learn physics for physics, just learn with examples. Okay. So you won't find it difficulty. Now, what is theta? Angular displacement. Like in linear, in linear motion, we have displacement, velocity, acceleration. Same way, we have angular displacement, angular velocity, angular acceleration. Is that clear?
Yes.
We have angular, but what is the unit of this one? Can you tell me? What is the unit of angular displacement? Okay, displacement is measured in normal displacement, measured in distance is measured in meters. Velocity is measured in. Keep the phone there. No, don't search now. I'm going to tell you the answers now. Okay. Now, what is velocity? Velocity is measured in. Speed is measured in kilometer per hour or meter per second. And acceleration is measured in meter per second square. Same way, this is measured in radians. Radians per second. Radians per second square. Got it? This is rotatory motion. Now, circular motion and rotatory motion is measured in radians. Is that clear? We don't say degrees. If at all it is there in degrees also, convert into radians. This is important, very important. If it is giving in degrees also, convert into radians. Never do directly. Never do directly. So we have, okay, we'll come back. But what is alpha here? Alpha is angular acceleration. So the formula for that is d square theta by dt square. Okay, d square theta by dt square. Is that clear? So what is the formula now? I into d square theta by dt square is equal to how much? Minus mb, because it is restoring torque. Clear? We are equating both of them. Tau is equal to I alpha, tau is equal to mb sin theta. We equated both. If angle is small, if angle is small, how much? Maybe 5 degree to 10 degree. Then sin theta is equal to theta. Is that clear? So how much when you say angle is small, what do you mean by that? If it is, maybe it is 5 to 10 degree, not more. In that case, take sin theta is equal to theta. Is that clear? Because it will become pi by 18, pi by 9. That is the reason. It becomes very, very small. So now I am writing here I into what? I into d square theta by dt square is equal to what? Minus md into theta. Is that clear? Now cross multiply this. D square theta by dt square is equal to how much? Minus mb theta by I. Is that clear? Minus mb theta by I is the formula. Let's copy this now. Now, okay, so d square theta by dt square, that is equal to minus mb into theta. So now, okay, we will go back again. See here, we have, what is this? See here, omega is equal to what? D theta by dt. And what is omega square? Omega square is equal to d square theta by dt square. Is that clear? Can we write like this? So now, and one more thing, what is omega? In some books, they say angular velocity. In some books, they say angular frequency. I say both of them is same. Do you agree? Angular velocity formula is omega is equal to d theta by dt. Angular frequency formula is 2 pi nu or 2 pi by t. But I say it is same. But how will you prove it? I will tell in simple words. This is angular velocity. This is angular frequency. Angular velocity is how much displacement in how much time. How much displacement in how much time. Means what? Like suppose this is the starting point. O is the center. A and B. A is the starting point. B is the ending point. And theta is the angle. D theta is the angle. And dt. How much angle is made in how much time? That is angular velocity. But angular frequency is in how much time it took to complete one rotation. It started from O, A, and ended at A. It came back to A. And how much time? Capital T. What is capital T? Time taken to complete one revolution or one rotation. Time taken to complete one rotation. Is it not the same? One rotation will be how much? How many radians? 360 means 2 pi. Is it not the same? See? Angle is how much? 360. 360 means how much? 2 pi. How much time? Time period. Time taken to complete one revolution is capital. Is it not the same? Same. Got it now? So that is why in fourth lesson, in circular motion lesson, they told about in grade 11. In fourth lesson, they told about angular velocity. In seventh lesson, they told about angular frequency. Which no one was interested. Everyone was busy in online classes, online exams, but that is a difference. Got it now? Note down somewhere this one. This is very, very important. Students, they don't have the clear picture about this because if you write any entrance examination, they are asking one question from this concept actually. Okay. Now, so what happened now? Now, can I write now this value as omega square? This is omega square is equal to minus md theta by r. What is that value? That value is equal to how much now? That value is equal to t is equal to how much it will be? T is omega square. Okay. Now omega square value will be equal to how much? 4 pi square by t square. Okay. Or I will not write like this. I'll write omega is equal to how much? I'll write magnitude only. Okay. Because minus we cannot find out the value. mb by r. mb theta by r. But what is omega here? 2 pi by t. Is it not? So 2 pi by, I'm equating both of them. 2 pi by t is equated to what? mb square root of mb theta by. So t is equal to how much? T is cross multiply. T is equal to t will come out. It will become 2 pi under root of I by mb theta. Yeah, I by. Is it the same? Yeah, I by mb theta. So if theta is very small, just ignore it. Okay, we need to take that into consideration. So that will become what? Okay, so that will become t is equal to 2 pi I by mb. Means what? It will start oscillating. Like suppose if we keep a magnetic needle, have you seen a magnetic compass anytime? Magnetic. If suppose already it is kept in the Earth's magnetic field, it start oscillating. Have you seen that? It won't be stationary. It start oscillating because Earth is having a uniform magnetic field. Earth is in the uniform magnetic. It start oscillating like this. Slightly. Means how much time it is taking to complete one oscillation. This is one oscillation. It started from here. See here. It went here, came back here. Again, this is one oscillation. Got it? How much time it took to complete one oscillation is said to be time period. That it depends upon what? Moment of inertia. M is what? Magnetic moment. E is a magnetic field. Just substitute the value, you will get the time period, time taken to complete one rotation, one oscillation. Sorry. Clear? Is this clear? You might ask me, sir, why did you suddenly remove that minus there? Because we cannot find out it is only the magnitude, it's not the direction. And second thing, where one is about that. Second thing is you can never find out the square root of a negative number. You can never find out the square root of a negative number. Did you find out the square root of minus 1? Square root of minus 1. is I, complex number. Square root of -2 is not possible. So that is why we remove that value. Got it? That is the only reason. Okay, behind it. Two reasons. One is we are finding the magnitude. Second is it's very difficult to find out the square root of a negative number. Okay. Now, this was about the time period. Last we will find out energy. Okay. Very simple. Last only two steps. What is the energy formula? Go back to the rotatory motion. The 7th chapter in the grade 11 was very important. I don't know how much it's sorry, but I don't know. But it was very important. System of particles and rotatory motion chapter was very important chapter. So we have U is equal to, see here we have energy is equal to what we write, energy or work done is equal to F dot S. Remember this one? In rotatory motion we have U is equal to integration of tau theta into dt. What is tau? Here when you are taking force in rotatory motion it becomes tau. Displacement in linear motion will become angular displacement in rotating motion. Got it? So now what will happen? Energy is equal to energy of a rotating body in the magnetic field is given by what? Tau is equal to what? Mp sin theta. Tau is equal to Mp sin theta. Now, so what do we write here? Mp is constant. Integration of sin theta. Integration of sin theta is minus cos theta. Okay? Integration of sin theta is minus cos theta. So minus Mb cos theta. Is that clear? Minus Mb cos theta. Or we can write minus M dot B. Why dot? Because it is a dot product. A dot B is equal to what? AB cos theta. A dot B is AB cos theta. Is that clear? Clear? Oh, that's right. Okay, so this completes the second derivation. This we did yesterday, but anyways, we're trying to revise it again. Please check the syllabus. Please do again, once again. Go back to home. Take out. I have given a printout of the syllabus in the class, but I don't know whether you have is there with your. See, once again, I'm telling you that the syllabus to complete this syllabus. No, this is not. This is the part of the previous one. Now, what you will do your homework today? You go back to home. This is a recap by before you sleep. Just it will take 10 minutes. The second thing is take a printout of all the syllabus, one side. Do it today. Why? Because even teachers also forgot. Because last 3 years it is continuously changing. 1920 it changed. 2021 it changed. 21-22 it changed. Now this is 22-23. Your academic year is 22-23. It's again changing. So even teachers don't remember, even you don't know what is happening. So better take a printout of the full curriculum. Download 22-23. Go to CBSE website, CBSE Academics. Okay, CBSE Academics. Go there. You will find elective paper like that. Click on that. You will find all the subject physics, chemistry, and all. Download that. Okay, 22-23 syllabus. Download it. Take a printout on one side. Don't take the printout on. Don't take all the printouts also. It is like grade 11 and 12 together. Only 12th syllabus is a PDF copy. 12th syllabus. Only the 12th syllabus. Only theory part. So it takes only 2 or 3 pages. That also when you take the printout one side. Don't take the printout double side. Cut the corners. Paste it on the first page. One. Anyways, you're not using this. Right? You're not using these 3 pages. You're not using it. Cut it, paste it. For physics, chemistry, bio. If you find a deleted portion also, please paste it somewhere. Do it today. That's the homework I'm giving you. Why I'm telling you? Because even while I'm teaching also, we can put tick over there. Means this will be completed in the class. Is that clear? This will be completed. You will have an idea. Otherwise, we are in a board in a sea. You don't know where you are going. Is that clear? Why I am telling you? Because even teachers, even when I was teaching, I even didn't see that. I thought I was going with the previous one. But when I saw the syllabus, I was completely, I thought earth magnetism, which was not there in the syllabus. You remember? That happened with me. So it can happen with anyone. So please take a printout, paste it there. And 22-23, very, very clearly I'm telling you. 22-23 syllabus only. Not 21-22. Paste it, cut it, paste it away. For all the subjects. Do it today itself. You have the printer with you? You have printer with you? You have the printer, no? Black and white printer. Okay, take it. If you don't have, buy a printer. Okay, it will be only 200 to 50. Okay, buy it. Buy some paper, keep it ready. Anytime you can take out. Okay. And also, most of the time, when I'm giving a worksheet, also don't be on the screen, most of them. Take a print out and try to solve it out. It's the best way. Okay, don't spoil your eyes. Okay, because the blue light of the, I'm telling you, the blue light which is coming out of the screens, whether it is mobile phone or tablet or the laptop, the blue light is not good for the eye. Okay, it spoils. And there is a therapy called light therapy. I came to know a new term called light therapy. Earlier we used to have physiotherapy. Then light therapy, a good white light is a good one. Green, I think, I don't know. Blue is something good, I think. Not the red. Red is not good for the eyes. Red, orange, color lights, or not good. Even green also, I don't think so. Just check with the Google, go to Google and find out study about light therapy. Which colors are good for the eyes. So that also matters. So blue is this light which is coming from the screen, so it's not good. If at all, if you're using also, use it in a daylight, like normal lights. Okay, clear? So we'll stop here for today. Okay, and we'll continue tomorrow. Tomorrow, what time you want the class?